So let me check the answers. John Frederick C. Kosawa. Robinson C iko sawa. Darrell C iko sawa. Marsh C, Nelvin C, Gift C iko sawa. Regina C iko sawa. Cynthia Woodward Aladwa. Very good. So we all agree that C is the element with young metallic structure. So our explanation for that is because element C is a good conductor of electricity in both solid and liquid state. So which particles are responsible for electrical conductivity in element C, in substance C? Because it conducts electricity in both solid state and liquid state. So which particles are responsible for the conductivity of that element? Ronnie, we just write the answers. Robinson, not valence electrons. Robinson, that is not correct. Darrell, hiyo iko sawa. John Frederick, that is okay. Aladwa, that is okay. Debra, that is okay. The localized electrons, Wayne, iko sawa. Mugas, hiyo ni mchanganyiko maalum. That one you will not score. Even in liquid state, hakuna mobile ions if it is a metal. Mugas, even in a liquid state, as long as it is a metal, in the liquid state, bado iko tu na delocalized electrons. So it is delocalized electrons. Ronnie Cliff, that is good. Cynthia, thank you. That is good. Isaac, delocalized electrons. Brian. So we all agree. Metals, any metal, be it in liquid state or in solid state, they conduct electricity. And the particles responsible for the electrical conductivity are known as delocalized electrons. Nothing else. We must just write it, delocalized electrons. If you can take any other thing, then you raise missing marks, losing marks. Then part B has a molecular structure and exists in gaseous state at room temperature. So which one has a molecular structure and exists in gaseous state at room temperature? John anasema E. John anasema ni E. I agree with that. Elvis E. I agree with that. Thumbs up for the first 5, right? That is what I'm doing here. Mugas. Correct. Isaac, correct. We have got Deborah, correct. Oduor, correct. Cynthia, correct. Very good. So we all agree that it's E. Now, other than E, yeah, it is E. It is only E. Now, the criteria that we use in identifying such, we always say the element that has a melting point below room temperature. And in fact, the boiling point. If it boils below room temperature, then it means at room temperature, it is in liquid state, has low boiling point and melting point. Robinson, you don't say has low boiling point and melting point, that is general. But for you to confirm that it is a liquid at room temperature, it is the boiling, I mean, to confirm that it's gaseous. Let me see just a minute. It's gaseous. Very good. For you to confirm that it is gaseous at room temperature, it is the boiling point that will determine that, not even the melting point, because the boiling point is the temperature at which, the fixed temperature at which a liquid changes to a gas. So for it to be in gaseous state, it must have changed from a liquid to gas. So if the boiling point is below the room temperature is around 25 degrees Celsius. So if the boiling point is below 25, then it means whichever temperature that is below 25, it changes into a gas. Then from there up to room temperature, kuendelea bado inabaki in gaseous form. So if it has a boiling point that is below the room temperature, then it exists in gaseous form. That is good. Boiling point. For liquid at room temperature, you check the melting point. Liquid at room temperature, you check the melting point. If it melts below room temperature, but boils above room temperature, then it is a liquid at room temperature. It has to boil above the room temperature. When you talk about room temperature, now we are talking about 25 degrees Celsius. Tunaangalia the boiling point. Like, can you give me an example of a molecular substance that exists as a liquid at room temperature from that table? Any substance that exists as a liquid at room temperature from the table? Existing as a liquid at room temperature, we have element E from Ronick leaf. Ronick leaf has said it is element E.